Hello students, so today in this video I will explain you this question which was asked in class 12th physics board exam of CBSE last year in 2022. This question says that a thin equiconvex lens of radius of curvature capital R made of material of refractive index mu1 is kept coaxially in contact with an equiconcave lens of the same radius of curvature and refractive index mu2 greater than mu1. Question is find the ratio of their powers and the power of the combination and its nature. So let's first see what is equiconvex and equiconcave lens. So equiconvex means a convex lens whose both surfaces will be convex and the radii of curvature of both the surfaces will be same, will be identical or equal. Similarly, for the equiconcave lens also, the radius of curvature for both the surfaces will be equal and both surfaces will be concave as I had drawn in the question. So this question is based on Lensmaker's formula, and if you remember Lensmaker's formula 1 upon f, that is equal to mu minus 1 and 1 upon r1 minus 1 upon r2. What is mu here? Mu here is the refractive index of lens material relative to the medium in which it has been kept. Okay, yeah, so in the question it is given that refractive index of the first lens is mu1 and that of second lens is mu2. So for first lens, suppose I say focal length is f1 and for the second lens let's say focal length is f2. So for first lens you will write 1 upon f1 is equal to mu1 minus 1 and 1 upon r1 minus 1 upon r2. So this is a very important thing here. You should notice that for the equiconvex lens, for the first surface, the center of curvature will be on the right side. So its radius of curvature for the first surface R1 will be written as plus R because it is on the right side. So using sign convention, you will take this distance positive. And for the second surface, the center of curvature will be on the left side. So for this, the radius of curvature will be taken minus R using the sign convention. And similarly, for the equiconcave lens, first surface, the center of curvature will be on the left. So its first surface radius of curvature will be on minus r, and for the second surface the center of curvature will be on the right side, so radius of curvature for the second surface will be plus r. Now let's put the values in this formula. 1 upon r1 minus 1 upon r2. So for the equiconvex lens you will write 1 upon r1 as 1 upon plus r minus 1 upon r2 as minus r, and what it will be, this will be mu1 minus 1 and 1 upon r minus and minus, it will be plus. So 1 upon r plus 1 upon r, this will be 2 upon r, this is 1 upon f1. And if you remember, 1 upon f1 is also will be the power of the lens because power is defined as 1 upon f. P is equal to 1 upon f. If you take focal length f in meters, and it will be 100 upon f if you are taking f in centimeters. Anyway, so this is the focal length of the first lens we found. Similarly, for the second lens, you will write 1 upon f2 is equal to mu2 minus 1 and 1 upon r1 will be for the first surface, the r1 is minus r, minus 1 upon r2 will be plus r. And if you simplify this, so it will be mu2 minus 1, 1 upon minus 1 upon r minus 1 upon r, it will be minus 2 upon r, so it will be minus sign here and 2 upon r. So this is your 1 upon f2. So question was, first part was with the ratio of their powers. So let's write first part, ratio of their powers. So power, suppose first lens is p1, power of second lens is p2. So p1 will be 1 upon f1 upon p2 will be 1 upon f2. So it will be f2 divided by f1, right? Or we can simply just put values of 1 upon f1 and 1 upon f2 we had just found out. So here we have 1 upon f1 is mu1 minus 1 into 2 upon r divided by 1 upon f2 is mu2 minus 1 2 upon r. So this 2 upon r will get cancelled and we have minus sign also here, don't forget that. And so we have mu1 minus 1 divided by minus times mu2 minus 1, so we can put this minus sign here and mu2 minus 1 here. So if you notice it, this value right hand side, so because mu1 and mu2 both will be more than 1, both will be greater than 1, we hope so. So this whole thing is positive, but outside there is negative, so this ratio is negative. So the power of the combination, the ratio of their powers, and the power of the combination also we have to find out. So let's do the second part. Power of the combination, P will be P1 plus P2, because focal lengths get added in reciprocals. 1 upon f equal to 1 upon f1 plus 1 upon f2 using the length combination formula. So it is coming from the formula 1 upon f is equal to 1 upon f1 plus 1 upon f2. This is the formula for combination of focal lengths for two thin lenses kept in contact. So 1 upon f is the power of the combination, and P1 and P2 are the powers of the two lenses. So P1 is your 1 upon f1. So 1 upon f1 is mu1 minus 1, 2 divided by r, plus P2 is minus mu2 minus 1 into 2 upon r. So if you take the common terms together, 2 upon r, it will be mu1 minus 1 and minus mu2 plus 1. So this 1 will get cancelled, and now you are left with mu1 minus mu2 divided by, this will be multiplied by 2 also, divided by r. And because it is given in the question that mu2 is greater than 1, so mu1 minus mu2 is going to be negative. So you can also write it like this, minus 2 times mu2 minus mu1 divided by r. So this is your combination power, minus 2 times mu2 minus mu1 upon r. So mu2 minus mu1 will be positive because mu2 is greater than mu1. It is given in the question. R and 2, all the things are positive, but whole thing is negative because outside there is a negative sign. So whole power is negative. So whole power is negative. That means the combination's nature is concave lens. It will behave like a concave lens, or you can say it will behave like a diverging lens, because concave lens has diverging capacity. So we got the answer to both the parts. So P1 upon P2 we got the ratio, and we got the combinations power also. Okay, so that's all was asked in this question. So I hope you understood this question, and thank you very much. Take care and bye bye.